All right, welcome everybody. So today we're going to continue to solve equations. Some of them will be degree 3, as you can see in this particular example, and I believe the next one. Um, and it's kind of a smorgasbord of things. We've got rational equations tossed in here, absolute value equations, radical equations. Like I've said before, this whole chapter 1 in this book is kind of a review of intermediate algebra. So things that would have spanned multiple sections before in the previous course have been, smushed into this into one section in this course. Okay, so it's not like an in-depth covering that we would expect that you would come to us with some knowledge of this already. It's more of a brief covering. So if you do need more in-depth covering, right, you can always Google some videos of that if need be. I mean, might be enough what we say here today. Okay. All right, so let's go ahead and start. All right, so I'm looking at this and I'm noticing that this equation has 4 terms. Okay, you can see 1, 2, 3, 4. And for me, anytime that I see that an equation has 4 terms, I do think of doing that factoring by grouping that we've used a few times now, okay? So remember, factoring by grouping is when you slice the equation down the middle, 2 terms on the left, 2 terms on the right. And then you factor out the GCF, the greatest common factor, from just the first 2. And then when you're done with that, the last 2, okay? So I'm looking at the 8x cubed plus 4x squared, and I'm asking myself, well, what can I pull out? What divides into both? So I can see 4 goes into both, and the highest number of x's that I can take out is 2. So I'm going to go ahead and divide by that. So that'll just leave me with 2x. And then remember, if you took it out, you still need to have the 1 there, right? It's not like there's nothing there. When I redistribute, right, inside, I should get back what I have here. So I definitely need this 1. So that 4x squared times 1 gets me 4x squared. All right. Okay, so then we have to take out the sign too. So I'm going to go ahead and take out the negative. And then what goes into both 50 and 25? Well, 25, right? And I want to pick the biggest something. And you'll notice that the sign changes because we factored out a negative. Number one mistake I see when I'm grading this is that students didn't change this sign right here when they factored out a negative. So make sure that you're doing that, okay? All right. So now you notice that these match, and that is a good sign, right? We want those to match. I'm going to do it in a different color, you guys, just to really highlight that these things match. So that's going to be one of the parentheses because that's the greatest common factor. That's what you factored out. And then what will be left over when you factor that out is the 4x squared minus 25. Now, what is new, because technically none of that is new. I mean, it's not like we've done it a ton, but it's not new. So what we can do now is that what's different is that we can actually go further. A lot of times it's stopped right here, but we can factor this further. This particular part is what we call a difference of squares. Okay, so there's actually 2 ways of solving it from that point. I'm going to show you one way, the first way, I guess I'll call it, and I'll show you the second way. They both have their benefits, okay? Yeah. So the first way is going to be by factoring. I think a lot of teachers choose this method of teaching because they know a lot of students forget their plus or minuses. And so that would be why they might want to pick this, okay? So if we have 4x squared minus 25, that can factor as a difference of squares. Difference of squares are my favorite things to factor because you're basically just square rooting each piece, right? Like what's the square root of this? So in other words, what times itself is 4x squared? Well, 2x times 2x would get us 4x squared. You're going to do the same thing to the back end. You're going to square root the back end. Okay, well, 5 times 5 is 25. So I'm going to put a 5 in. And the signs are going to be different. Plus, minus, minus, plus. Doesn't matter on the order, but they have to be different. Okay, so that's how we factor our difference of squares. So that would be one way of getting to the solutions. If I come back to my problem here, right, and I put that in place of the 4x squared minus 25. Okay. Then we're at the set each piece equal to 0 spot. So we're going to go ahead and set each one of these parentheses equal to 0. Okay. So we'll move the 1 over, making it negative, and then we'll divide by 2. We'll move the 5 over, making it negative. So we're going to get negative 5 halves. And then we'll move the 5 over, making it positive. There we go. We have 1, 2, 3 solutions, which makes sense because if you go back to the very beginning, our highest exponent was 3. So we know we found them all. It's not like there's someone missing that we didn't find, okay? Now, the second way of solving it besides using the difference of squares. Now, by the way, the difference of squares formula is technically this. If you're factoring the difference, in other words, subtraction, of 2 perfect squares, then it's going to be a plus b and a minus b is the technical formula for the difference of squares. All right, the second way, which is really what I do when I'm solving, but I have noticed when students use it, they forget to put a plus or minus. When you come in here and you're solving this, in other words, instead of, this step right here, this step right here would be missing. For the second way, you would just go straight from the 2x. So let me kind of write that step down, okay? I'm going to write down this step, the 2x plus 1. Okay, you would set each one of these pieces equal to 0 right here. So the factoring never happens. Okay. And then this one we already solved. So let's just write the answer down. No need to reinvent the wheel. On this one, move the 25 over so that it's a positive 25. Then divide the 4 out. So you're isolating the square term. This is us solving by using square roots, okay? We did it, I think 2 sections ago, okay? So we're going to square root. And we said anytime that we square root both sides of an equation, we have to remember our plus or minus. And then you're just going to square root each number. Like the square root of 25 is 5. The square root of 4 is 2. And so you can see we still get 1, 2, 3 solutions, right? We have positive 5 over 2. We have negative 5 over 2. And it completely matches with the 2 solutions that we got over there. We have a plus and a minus, okay? Now, pros and cons. I feel like this way over here is shorter, which is why I technically use it. But if you're one of those people who, when you're square rooting, you forget plus or minuses, right? Then maybe this method would be best for you. Plus, the factoring a difference of squares is not something that's going to go away. You are going to be doing it for the rest of your mathematical careers, okay? And so getting used to seeing that and doing that is not a bad thing. So that's probably another reason why teachers like to teach it that way, okay? All right. Man, this is weird. Every time I erase it and then I click on the marker, the mark comes back. So I guess it's going to stay there, guys. All right, let's go on to the next one. Now this one, if you go about solving it in your usual, I'm going to isolate the x cubed. This would be wrong, okay? So let me show you the wrong way. And I'm emphasizing this because it's wrong, but man, it looks so right, okay? So that's why I'm pointing it out. It's like, why are you wasting time teaching me the wrong way? Well, watch. You're going to go, that looks good. I move the 1 over to the other side. And then I'm going to go ahead and divide by 8. So we get x cubed equals 1/8. Then to get rid of the cubed, we will cube root. So we get x equals, and remember, I don't need a plus or minus with the cubed root, right? It's only even roots that need plus or minuses, okay? So a square root, a 4th root, a 6th root, okay? And we're just going to cube root these. So the cube root of 1, well, 1 times 1 times 1 is 1. And the cube root of 8, well, if you didn't already know it, 2 times 2 gets you 4. Multiply it by another 2, boom, you've got 8. So the cube root of 8 is 2, okay? Now notice this is only one answer, you guys. This right here is one answer, and that should send off some red flags, right? Like something's wrong. Mecklenburg told me that I should get three answers on this one because the highest exponent is 3, okay? we only get one answer, which we know cannot be correct since the highest exponent is 3. Okay. So we lost some solutions is the moral of the story. I mean, it turns out that this answer is going to be one of our answers. So it's not like completely wrong, you guys. But I'm missing 2 more, right? So something's up. Okay. So let's kind of shrink this down so I have room for the other ones. All right. So let's show you the correct way of solving it. And it actually just requires a formula that you kind of have to lock in. Okay. For those of you math nerds, there is, just like the quadratic formula, a cubic formula. That would probably be pretty simple on this particular case, I think, to use. It's been a while since I've thought about it. But that's not something we teach in like college algebra, at this level. It was one of my upper division math classes. All right, but you might look into it if you're a math nerd, especially the history behind it, because there was some arguing over who came up with it, as usual, right? It seems like somebody's always stealing somebody else's credit when it comes down to these math and science theorems. Okay. All right, in this case, formula. Okay, so the right way. So let's go over 2 formulas. One is going to be called the sum of cubes, and one is going to be called the difference of cubes. Unlike squares, there is only a difference of squares, you guys. That's it. There's no sum of squares, okay? But with cubes, we have both. So if you find that you have cubes summing, in other words, adding, so the sum of cubes, then that will factor in the following way. Okay. If you have a difference of cubes, so minus, it will factor very close, but subtle differences. So, okay, so these are some formulas that will come up, forever. Okay, even in my calculus 1 and 2, they keep creeping up. Now, there is a kind of an acronym to help you remember. It's called SOAP. So SOAP, SOAP. The S stands for the same. Oops, the O stands for opposite. And then AP stands for always plus or always positive. Same sign, opposite sign, always plus. So what that talks about is, if you guys notice, if you look up above, they actually have all the same letters, right? A, B, B, A squared, A, B, B squared, B squared, right? That's not what's changing here. So if you just memorize the letters, okay, then SOAP will help you understand what sign should go in there. So according to SOAP, the first sign here should be the same as the original sign. The second sign should be O opposite the original sign. And the last sign should be always plus or always positive. Now, if you go down to the difference of cubes, right, the first sign should be the same as the original, minus minus. The second sign should be the opposite as the original. And the last sign is always plus, no matter what. Okay. All right. So same sign, opposite sign, always plus. Same sign, opposite sign, always plus. And that'll help you remember this because it is something you're going to want to remember. I'm one of those teachers who thinks that memorization is good. I don't think of it as a horrible thing to require for students because they'll be grateful when they go on to the next class and they're like, oh yeah, that's a sum of cubes. That's in my brain. Okay, they don't have to go Googling it or whatever. It's there ready for them. All right, so knowing that, let's go in here and let's go ahead and solve by using a difference of cubes formula, okay? So we are going to use the difference of cubes because we have subtraction. Okay. All right, so for the difference of cubes formula, okay, you know that you have to find or have to rewrite your equation so that it looks like something cubed minus something cubed. Ours doesn't quite look like that yet. So I need to figure out what cubed minus what cubed, okay? Well, we saw a second ago that 2 times 2 times 2 is 8. So this must be 2x. If you take a 2x and you multiply it, 3 times, right? 2x times 2x times 2x, you will get 8x cubed. And 1 is nice and easy. Well, 1 times 1 times 1 is going to be 1. Okay. Now, the reason why that's important is because that's what's going to help you find your A and your B in the formula. Okay, so the formula being this guy. A cubed minus B cubed equals same sign, opposite sign, always plus. Okay. All right, so we now know that A is 2x, and we know that B is 1, right? Okay. So if we were to fill this out, we only fill out the right-hand side, by the way, you guys, okay? You already have the left-hand side. So if I were to substitute this into the formula, it would be, so we're going to use this side, right? A minus B. So it's going to be 2x minus 1. And then A squared would mean 2x squared. And then A is going to multiply by B. And then plus B squared. Don't forget all of this equals 0, right? If you look at our original problem, there's an equals 0 on the right-hand side. Okay, so we got parentheses 2x minus 1. 2x times 2x is going to be 4x squared. 2x times 1 is 2x. And then 1 times 1 is 1. Now this piece, you can always, this first piece, you guys, you'll always just set it equal to 0. That'll be the easy one to get the solution off of. Move the 1 over, make it positive. Divide by 2. X equals 1 over 2. Now notice, as a side note, matches, right? We said, hey, that is a solution. The only problem is we lost 2 others, right? So then we're going to set the second piece equal to 0 also. We're going to set this piece equal to 0. And this will never factor. This is always going to be something that you'll have to use the quadratic formula for because it does not have rational solutions. If it did, they would have changed the formula to show you the rational solutions, okay? So this will always be something that you'll use the quadratic on. I'm going to go ahead and shrink, or let me move it, and I'll put a little side note over here. This will always require the quadratic formula. Okay. So since we've been using the quadratic formula quite a bit, I'm just going to go right to it. Okay, so x equals negative b, so negative 2, plus or minus the square root of b squared minus 4ac all over 2a. I'm going to need some space, guys, so let me move it up. Okay. So we got x equals negative 2 plus or minus the square root of 4 take away 16, because of 4 times 4. Who cares about times 1, right? All over 8. So 4 take away 16 would be negative 12. And I'm going to go ahead and for negative 12, right? Let's go ahead and just break that guy down over here. We know we have to pull out an I. But then we know that 12 is 4 times 3. So 4 can square root, right? So it's going to be 2I root 3. And then we're going to have to reduce because the i's in the nose, right? All are divisible by 2. So it looks like we're going to get, if we divide them all by 2, we get 1. I'm not going to write this one, but I could. Wouldn't be wrong. Bam. Now technically that's 3 answers, you guys, because we have 1 here with the 1/2. And then we have -1 plus I root 3 over 4, which is one solution, and -1 minus I root 3 over 4. So that is going to be your 3 solutions. Looks like we got them all. We know we're not missing any. Okay. All right. And there are definitely tons of resources if you're like, hey, I want to practice this sum of cubes and difference of cubes, over. Not the intent of this video. So Google that if you need some more practice, or contact me and I can locate some good sources for you. Okay, we've already solved rational equations in this class. So the only difference probably here is that maybe we'll have to solve some sort of quadratic in the end. So let's go ahead and go in and do it. So if you recall, the very first thing that we had to do when we were solving rational equations is we had to find out what were our restrictions. In other words, what made the denominator equal 0. And you can just eyeball it, right? Or if you need to, you can set each piece equal to 0 in the denominator. So you could say, okay, I'm going to set x minus 1 equal to 0. And I'm also going to set x plus 1 equal to 0. So it looks like my restriction here would be x equals 1. And my restriction here would be -1. Okay. Now those aren't allowed because if you plug them in, right? If you plug a 1 in right here for x, 1 minus 1 gets you 0 in the bottom. And so that would make no sense. That's what our first term would be. And as you know, that is undefined. So our very first term would be a word, undefined, right? So that doesn't make any sense. So, oops. So we're going to go ahead and make sure that we write our restrictions first, because sometimes they'll show up as solutions and we've got to be wise enough to know that those are extraneous solutions. Okay. All right. And then after that, we multiply by the LCD. So the least common denominator here is going to be everything that shows up in the denominator, x plus 1 and x minus 1. So we are going to multiply everything by an x plus 1 and an x minus 1, okay? Everything meaning all terms, all the numerators, right? Oops. All right, and then you're just going to start crossing stuff off. The point here, why do we do this? To get rid of the fractions. And look, the denominator's gone here. The denominator's gone here. And the denominator's gone here. If all the denominators are gone, then there's no longer fractions, right? So what remains is x plus 1 times a 1, 2x times an x minus 1, and 2 times an x minus 1. All right, so multiplying by 1 isn't going to do anything. So x plus 1 times 1 is just x plus 1. We'll go ahead and distribute this -2x and this 2. Okay, so -2x. Don't forget when distributing a negative that the signs have to change, right? So this should be plus. And then we are going to combine like terms on the same side of the equal sign. I'm going to go from highest exponent to lowest. So I'm going to write this -2x squared first. Then after him, I'm going to combine these two x's together. And then the plus 1. Now remember, you have to make the decision which way you're going to move things. I always try to keep the leading term positive. Right now it's negative. So that tells me that I want to move everything here over to the other side. Okay. And doesn't matter how you do it. I am going to do it kind of in pieces because I want to make sure that it makes sense to you guys. So I'm going to start by taking away the 3x and taking away the 1. Whatever you do to one side, you got to do to the other. And then I'm just going to shoot this guy over to the other side so that he's positive. I don't want him to be negative. All right. I'm going to use the AC method. I could use the quadratic formula. That'll work too. All right, so 2 times -3 gets me -6. So we need factors of -6 to add up to the middle number of -1. So I just start writing what makes -6. So I know 3 times 2, -2 times 3, one of those. So I need -1 when I add. All right, so these ones will add up to -1 when I add. So those two are going to be the winners. Okay, so we're just going to go right to it. Factoring by grouping. The front stays the same. Insert the two numbers you just found with X's after them. And the last stays the same. So the front stays the same. The last stays the same. You just rewrite the middle term. We're going to slice it down the middle like we did on our very first problem today. And I'm going to factor out an X. And I'm going to factor out a +1 because, well, I don't want to change it at all. And that's the only number I could factor out and not change it. Why do I not want to change it? Because I want these to match, right? So 2x minus 3, and then x plus 1. There we go. We're ready to set each piece equal to 0. So when we do that, on this one, add the 3 over and then divide by 2. So we'll get 3/2. And on this one, when we set it equal to 0, subtract the 1 over. So you get -1. Now, remember, don't box them and call it a day. I did that all the time and got burned when I got my test back. -1 is a restriction, you guys, right? I'm just going to draw a little arrow up here because that's why we're going to cross this guy off. So our only answer to this is going to be 3/2. Okay, 3/2. All right. Okay, so another chance to practice. All right, so we have to get our restrictions, but it's easiest to get your restrictions when the original rational equation is in factored form first, okay? So this middle denominator, right, is not factored. That quadratic in the denominator right there, remember quadratics, anything with exponent of 2? It's not factored. So I'm going to go ahead and look for factors of the last number, -3, to add up to the middle number of 2. So when I start thinking about what multiplies to make -3, either -3 times 1 or -1 times 3, right? I need this to add up to +2. So winner right there. All right, so we got x minus 1 and x plus 3 going in the parentheses. All right. So now I can clearly see my restriction. In fact, I mean, I don't even have to set them equal to 0. These ones would be pretty easy to just eyeball. Okay. If I was just eyeballing it, in other words, what would make the denominator equal 0, right? Well, I can tell that -3 when plugged in here, -3 plus 3 is 0. So I'm going to put -3 on the list. If you can't see it, just set the bottom equal to 0 and you will get the -3, right? I can tell for this one, if I plug in for the x a +1, 1 minus 1 would be 0, right? So 1 must be a restriction. Again, just set it equal to 0. There you go. All right, so those are our restrictions. The LCD here is everything that we see in the denominator. So I see an x plus 3 for my LCD. I also see an x minus 1. So I'm going to multiply x plus 3, x minus 1 to every single term. Top only, guys, top only. I'm just going to start canceling stuff. Remember, these denominators better go away or you picked the wrong LCD. Oh, that feels good right there. Okay. All right. So then what's left is 2 times an x minus 1, a -2, and then a 3x times x plus 3. So let's go ahead and distribute and see what we would get. So if we distribute, we get 2x take away 2. And we get 3x squared plus 9x. Okay. All right, so I'm going to go ahead and combine like terms. So we got 2x, and then -2 and -2 make -4 because we're adding, not multiplying. And we said we want to keep our squared term positive. It's positive, which means leave it on the right-hand side. So I am going to move all of these that way, right? Okay, so I'm going to subtract 2x from both sides of the equation, and I'm going to add 4 to both sides of the equation. So that's going to get me 0 equals 3x squared, 7x plus 4. And I'm telling you, these problems are so long that usually they make it factorable, so you don't have to go through the long process of the quadratic formula. So I'm hopeful every time I do the AC method. So 3 times 4 is 12. I'm looking for factors of 12 that add up to 7. 3 times 4, right? 3 times 4 is 12. 3 plus 4 is 7. So factor by grouping. So the front stays the same. Insert those new numbers you found to rewrite the 7. And then the back stays the same. We'll slice this guy down the middle to do our factoring by grouping. And we're going to pull out a 3x because that's what goes into the first two. And we're going to pull out a 4. All right. And so then if we factor out the x plus 1 that they both have, right? Okay. Then what would be left over after we take this x plus 1 out would be 3x plus 4. And now we're ready to set each piece equal to 0. And we just have to make sure that when we get done, they aren't restrictions. So this one would get us -1. Let me go back. Hey, it's not a restriction, you guys. +1's a restriction. So box that guy. And then if we set 3x plus 4 equal to 0, you'll get 3x equals -4. And you'll divide by 3. X equals -4/3 is going to be our second solution. Highest exponent, well, the original equation was rational, right? But our highest exponent at this stage of the game, right, was a 2. And so we did find all 2 for that particular piece, right? Okay. Let's see here. Okay, so that's it. So we're moving on to absolute value equations, okay? So the absolute value signs technically stand for what they mean is the distance from 0. Absolute values find the distance 0. So you might remember absolute value signs always make things positive, right? That is why they turn everything positive. We never allow distance to be negative, right? You have never in your life said, yeah, I live -4 miles away from my brother or my sister, right? Okay, so there's no negative distances, okay? Distances cannot be negative. Okay, so, and this even goes true into like on the complex plane. If we have, you know, the real axis and the imaginary axis, and somebody says this 3 plus 2i with these absolute value brackets around it, right? You would just go over 3 up 2, and you would find out what is that distance from 0. Okay, how far away is this dot from the origin, which you could kind of think of as 0. And so it really is finding distances or length, how far away something is from 0. A lot of different planes here, okay, or 2 here we're looking at, but in both. Okay, so for that reason, absolute values tend to have 2 solutions, okay? If I say to you, you know, here's some blanks with an equal sign 4, and I want to know, what could I put into the blank and get 4 out, right? Well, we could put in +4, right? because the absolute value of positive 4, well, how far is positive 4 on the number line away from 0? It's 1, 2, 3, 4 away, right? So it would be 4. But I could also put negative 4 in. Remember, the absolute value of negative 4 is positive 4, right? And that's because negative 4 is also 4 away from 0. Okay. So there's actually two answers to this question as to what could we put in the blanks, right? We could put in 4, or we could put in negative 4. Okay. So often you will have two solutions. I say often because there's a lot of different situations where you might not have to, like, consider 0 there, right? What could you put in the blank to get 0? Well, the only number I could put in here to get 0 is 0 itself. Or even worse, something like this, which we'll talk more about in a second. This technically has 0 solutions, okay? But in the general normal case, you will get two solutions out of this, okay? I'm not going to cover absolute values set equal to a variable in this section, which is a whole nother thing too. But you can look up videos on that if you want to, but it's not going to be on my test or in this section, okay? All right, so what we're going to do to solve this is we're going to do two cases. We know there's two answers. We just discussed that. So how do I go about getting those two answers? Well, here's how. You're going to take the stuff that's inside the absolute value bracket, the 2x minus 1, and you're going to set it equal to both positive 5 and to negative 5. Now notice I'm only changing the right-hand side. I get students who change the stuff that's inside the absolute value brackets. You don't want to do that. What you're saying here is what we just said a second ago. If you have some empty brackets and it equals 5, then I could either put positive 5 in here and it would work, or I could put negative 5 in here and it would work. So that's why we're taking the stuff inside the brackets and we're either setting it equal to 5 or we're setting it equal to negative 5. It could be either one of those and still work, okay? And then you just proceed to solve these like you've been solving all semester long, right? So I'm going to go ahead and solve this first one. So I'm going to add 1 to both sides. And then I'm going to divide by 2. X equals 3. All right, same thing over here. I'm going to add 1 to both sides. And then divide by 2. There we go. There's our typical two solutions. And again, you could just plug these in really fast and see, let's say it's a test situation. I always made mistakes, littered my test with mistakes. If I would have just thought about checking, I wasn't mature enough, I probably would have gotten more things right. So I'm going to substitute in 3 and I'm going to see, does that work? And I'm going to substitute in negative 2 and see if that works. All right, 2 times 3 is 6. 6 minus 1 is 5. And the absolute value of 5 is 5. So that one works, right? 2 times negative 2 is negative 4. Negative 4 take away 1 is negative 5. The absolute value of negative 5 is positive 5. So that one works. So indeed, both of these check out. All right. Number 6. Okay, so let's see here. And before you begin doing your two cases, you always have to make sure you isolate the absolute value first, okay? So before doing the two cases, make sure you isolate the absolute value first. So what I mean by that in this case, right, we're going to have to isolate the absolute value. So that means we're going to have to get rid of these two things. And you would get rid of them in the usual order when you were solving, right? If you had this equation, 2x plus 1 equals 7, you always move the 1 first and then divide by 2, right? But we're going to go in that same method that you guys are used to. So we're going to move the 1 first. And since that 2 is multiplying, we're going to divide. Oops. If you find yourself distributing into some absolute value brackets, okay, you're probably doing the problem wrong. Okay, we will not be distributing into absolute value brackets in this class. Might be some context in which it's okay and can be justified, but it will not happen in this class. All right, so now we're ready to do the 2 cases, right? So the 2 cases being the stuff inside the brackets could be 3, or the stuff inside the brackets could be -3, and we'll proceed to solve these equations. So we get 3 plus 4, which is going to be 7. One. Okay. All right, so those will be your 2 answers, and you could just really quickly check those on your own if you want to. Okay, let's move on. Now, whenever you have the absolute value of x, any absolute value equaling a negative, these are my favorite because I don't need to do anything. The answer has to be no solution, because we just said that absolute values turn everything positive. So there is no way that an absolute value could ever equal a negative, since absolute values turn everything inside positive. That's as long as there's one term, right? Or one number. There is no way an absolute value can equal a negative. And make sure you spot these, okay? You could be like the algebra zombie, and you could just be like, set stuff inside brackets equal to 3 and -3, right? And you go in here and you'll get answers. I mean, look at this. I'm going to get -5, and I would get 1. And then you'll box those and you'll totally get the problem wrong. And you did a bunch of work to get the wrong problem, right? So remember, these are your favorite because you don't have to do any work, guys. You just go, oh, the absolute value equal to negative, done, right? Don't go in and solve. But you do have to have that deeper thinking going on, right? You can't just be in like this algorithmic way of thinking. I do this every time, right? You got to make sure that you're spotting that, okay? All right, now we can't really do like x plus 2 equals 0 and x plus 2 equals -0, right? Okay, it's not like that makes any sense. So you're just going to take the stuff inside, oops, and you're going to set it equal to 0. So there's no -0. So remember, we said the case of 0, that's when you're only going to get one solution. So here's our one solution, x equals -2. I always like to go back and make sure it makes sense. Yeah, when I plug a -2 in there, I get 0, right? -2 plus 2 is 0. Okay, so only one solution whenever it's set equal to 0. Now, what if you have 2 absolute value brackets? The good news is this is so very similar to what we've already been doing that I think you're going to be like, oh, okay, I can handle this. This isn't a massive change, okay? So we're going to keep the stuff on the left-hand side the same. So the 3x minus 1 is always going to stay 3x minus 1. It's only the right-hand side that's going to change, and it's going to be one case that's exactly the same and one case that's the exact opposite. And that should sit with you really well. So if you think about it, that's how we've been doing all of these, right? The left-hand side stays the same, 2x minus 1, 2x minus 1. It's the right-hand side that's the same and the opposite. So, I mean, this follows nicely, just like example 5, okay? So to give a strategy of attack, do 2 cases, one keeping the left side the same no matter what. When I say opposite, I mean literally the opposite. So whatever signs are there, do the exact opposite of those signs. So here it was a positive and a positive. So over here I did a negative and a negative. You're just always going to change both signs on the right-hand side, okay? All right, so let's go in here and solve these guys. So you know me, I got variables on both sides. I'm going to move the smaller to keep things positive. So 3x minus 1x, it's going to be 2x. Add the 1 over. And divide by 2. Okay, so there's one solution. Variables on both sides, move the smaller. So I'm going to move the negative 1x, smaller than 3x. So we got 4x, take away 1 equals negative 5. This one, this one. Divide by 4. You never have to check these. They always turn out to be correct. Okay, so those are how you do it if you have absolute value brackets on both sides of the equation. Those come up rarely, so it's easy to forget, but luckily it matches with what we would normally do. Okay. All right, you guys. Let's see. So from here on, we're solving radical equations for the rest on. What I'm going to do, I'm going to go ahead and make a separate video for that because I can see there's a lot of problems here. And I don't want you to come at it with an exhaustive mind, okay, especially those word problems at the end. So I'm going to stop it here. So this is going to be our 1-6 part 1. I'll do another video for 1-6 part 2. Take care, everybody.